There is a geometric sequence. That means every step you are going to multiply out here, where out is the common ratio. And then what they say is the third term is 972. And also the seventh term is 3/4. While the first one, second one, fourth one, something like that, we don't know yet, and at this moment we are not interested in it. So from the third term, we jump 1 time, 2 times, 3 times, 4 times. Then finally it will become 3/4. If we use the equation, that means from this one, we operate this will become this one. To write the equation, 972 times r power 4 times will become 3/4. We have this equation. So at this moment, what is the first term here is doesn't matter at all unless they ask you about the first term. But anyway, we have r power 4, we try to solve this one. I want r power 4, I don't want 972, so I divide both sides by 972 here. We get r power 4 is equal to 3/4 times 972. R power 4 is equal to 3/3888. We simplify it. R power 4 is equal to 1/1296. Afterward, we are going to handle power 4 here. The opposite of square is positive negative square root. Power 3 is cubic root. And also power 4, the opposite is positive or negative power of 1/4. So therefore, R is equal to 1/1296 power of 1/4 here. And don't forget positive or negative, there are two cases. This is the most tricky part here. If the power here is odd number, basically only one possibility, which is the same sign. But however, if the power here is even number, then you have to be aware that not only the positive case may also we should also include the negative case. Therefore, R can equal to positive 1/6 or R may equal to negative 1/6. Let's see whether it's enough to make the final decision. Okay, a power of 9. That means from the 7th one we jump 2 more times. So therefore, A7 and then we time R power of 2 should give us A9. Let's see what is this. 3/4 times R squared, which is 1/36, must be positive. Then we get 1/48 is equal to the 9th term. So this one is correct. The common ratio is 1/6. This is possible but may not be true. But they require must be true, so I can't accept it because we have one other possibility, negative 1/6. So I can't accept this statement. The third one is quite troublesome. If all the odd order terms add together until no matter what is n, so I may consider until infinity, add together is that smaller than a certain values. So we are considering not the original sequence, we are considering this sequence here. So we have this term 972, and then what happened every time is time R for 2 times, so time R power of 2. So it's a fixed value here. No matter R is positive or negative, R power of 2 is just 1/36 here. So we have the ratio 1/36. At the same time, we have to chase back what time 1/36 will give you 972. A1 times 1/36 give you 972, so in reverse, it's 972 T2 times 36 here. We get 34992 is the first term. About sum to infinity terms of geometric sequence. Because the ratio here is between -1 and 1, that's why we can apply this formula. It's the first term and then divided by 1/1 minus R. So therefore, sum to infinity here is equal to A34992. In paper 1, don't write this symbol, it's not correct. Anyway, over 1 minus R is 1/36. Then we get the sum to infinity is 35991.77 something. Compared with our boundary here 999, this one is less. So even if we add infinity terms together, it's never larger than this amount. So this statement is correct. It's never larger than this amount. So that's why we accept the third one. The answer is B.